Okay, now the next question is that how do they undergo chemical bond formation? We have already answered why do they undergo chemical bond formation. Now the question is how do they undergo chemical bond formation? Now they can undergo chemical bond formation either by transfer of electrons or by sharing of electron pair. A sharing of electron pair. Now the first one we will take the transfer of electron, the first one. Now why it is going to form, why it is going to undergo transfer of electrons. Now if an atom, if one atom has the following characteristics or the following properties, if an atom has the following properties or the following characteristics, then the transfer of electrons is going to take place. For example, if an atom has low ionization energy or low ionization potential, what will happen? If it is having low ionization energy or low ionization potential, then it will readily lose electron to form what? Cation. It will readily lose electron to form a cation. Second, so the other atoms should have, now what is forming cation? The other atom should have high electron affinity. Now if other atom is having high electron affinity, what is going to form? It is going to form an anion. So cation is formed, anion is formed. You can say that. If an atom is having low ionization energy, for example, it is having low ionization energy, it will readily form a cation, as you can see it here. Second one, if an atom is having high electron affinity, then it will readily gain electron to form an anion. So which element comes under this category? That is, elements of group 1, 2 and 3. They have low ionization energy. They readily form cation. And elements of group 15, 16 and 17, they come under this category of high electron affinity. They readily gain electrons to form anion. Okay, fine. Now, cation and anion is not sufficient to only to form what you can say the ionic compound. The cation and anion, they have to come closer to each other also. So for that particular purpose, they should have high difference in electronegativity. They should have high difference in electronegativity. Once they have high difference in electronegativity, generally the electronegativity difference should be greater than 1.9. Greater than 1.9. If the electronegativity difference is greater than 1.9, as the difference is increasing, then the electrostatic force between them increases. Because you see here, X plus and Y minus, between them an electrostatic force will result. And as the difference in electronegativity will be more, they will come closer and closer to each other. They will come closer and closer to each other, and it will form what? A strong electrolyte bond. It is going to form. So what I said you, they should have high difference in electronegativity. Generally difference in electronegativity should be greater than 1.9. It should be greater than 1.9. If the electron difference is greater than 1.9, what will happen? The cations and anions, they will come closer to each other. The electrostatic force of attraction between them will be stronger and they will come closer to each other. Now once they come closer to each other, do you think it is sufficient for the bond formation? No. One more condition is also there. That is, they should have high lattice energy. Now what do you mean by lattice? What do you mean by the word lattice? Lattice means definite geometrical structure. It is called as lattice. The solids, they have got a definite geometrical structure. So what is lattice energy? Lattice energy, listen carefully. The lattice energy is the amount of energy released. The amount of energy released for the formation of 1 mole of an ionic compound. Again I repeat, the amount of energy released for the formation of 1 mole of an ionic compound. That is called as the lattice energy. So higher is the lattice energy, because I said you earlier only, energy is inversely proportional to stability. So higher will be the lattice energy, means the amount of energy will be released which is higher. So less amount of energy will be there in the compound. If the less amount of energy will be there in the compound will be more stable and stable in nature. So hence for that particular purpose, the ionic compound, the electrovalent compound are stable in nature. So what we see the properties of an ionic compound, what should the characteristics for the formation of an ionic compound? Sorry, it's not the properties. It is characteristics is that it should have low ionization energy so that it readily forms a cation. It should have high electron affinity so that readily forms an anion. Cation anion is not sufficient. that is, it should have high difference in electronegativity, so the electrostatic force will be stronger. They will come closer to each other and it will form a bond. So will it necessary that is it only sufficient for the formation of a bond? We can say that no. It should also have a high lattice energy, because when a compound is formed, ionic compound is formed, it should be stable in nature, and stability is inversely proportional to energy. So the energy release should be higher. So if the energy release is higher, then the remaining energy will be less, and if the remaining energy will be less, the compound will be stable. So this is the condition for the formation of ionic bond, we can say that, or electrovalent bond. The compound which is formed as a result of this ionic bond or ionic this electrovalent bond, then that compound is said to be as ionic compound or electrovalent compound, we can say that. And here we are also having a term that is known as electrovalency, we can say that. What is electrovalency? Electrovalency is the number of electrons that is lost or gained for the formation of a compound, an ionic compound, is known as electrovalency. The number of electrons lost or gained for the formation of a stable ionic compound, or the formation of an ionic compound, is known as electrovalency. The number of electrons lost or gained, we can say that. For example, suppose if you are taking here, let me rub it a little bit. If we are taking here calcium, Ca minus 2E minus will form Ca2 plus. So here the electrovalency is 2, it is losing 2 electrons. Similarly, let us say it forms calcium chloride. Chlorine is gaining 2 electrons to form Cl minus. So 2Cl plus 2E minus gives 2Cl minus. It is gaining 2 electrons. So here also the electrovalency is 2, we can say that. So in this way, the number of electrons lost or gained for the formation of a stable compound, we can say that ionic compound, is known as electrovalency. Okay. Thank you.